morning, dear students. Myself, Dr. Priya, working as Associate Professor in Chemistry, Department of Humanities and Sciences, MLR Institute of Technology, Hyderabad. So, in today's presentation, we are going to learn about different types of corrosion reactions. So, in those, two were mentioned here, galvanic corrosion and waterline corrosion. So, let us go with first one, galvanic corrosion. So, this type of corrosion is defined as the process in which bimetallic compounds were present. The process in which if bimetallic compounds were present, then they are able to form one electrochemical cell on the surface of the metal. So, let us see how it is. This type of electrochemical corrosion, it is also known as bimetallic corrosion, and how it is defined as when two dissimilar metals are connected and exposed to an electrolyte, then they are able to produce one galvanic cell. So, if you notice, here I have considered the examples of zinc and copper. So, these are nothing but examples for two different metals, and these two are in contact with the presence of electrolyte, that is medium here. So, then the corrosion that is occurring in this kind of situation is what we call it as galvanic corrosion. So, anode metal, it is, as we know very well that always oxidation takes place at anode, and the metal which is placed in anode area will undergo corrosion reaction. So, as I told you, I have considered a system which is having two different metals, that is bimetallic in nature, that is zinc and copper, which were connected towards each other with the help of one medium, that is electrolyte. As a result, these are able to form a cell that is called galvanic cell. So, and then the metal which is placed in anode area, that means which is more electropositive, it involves in corrosion reaction first by involving in oxidation, that is by losing electrons. So, in these two, zinc, it is involving in oxidation by losing 2 electrons, that is oxidation, and it is able to convert into Zn plus 2 ions. So, this zinc usually involves in corrosion reaction first, okay, and then it undergoes corrosion, while cathode it is copper, because it is, if you notice the electrochemical series, it is acting like more cathodic to the hydrogen atom. I mean, hydrogen is considered to be the reference electrode first. Below that, if any metal, if it is present, then it is considered to be the more cathodic or more noble metal. So, copper, it is present in a position that is below the hydrogen, that is present in the galvanic series. So, zinc will be affected first, and later it will proceed towards the cathodic position. So, this is about galvanic corrosion. I am repeating. When two dissimilar metals are connected towards each other like zinc and copper, and they were in contact towards each other with the help of a medium, that is electrolyte, then immediately the type of corrosion that is going to form on the surface of the metal which is placed in anode area is nothing but galvanic corrosion. How to prevent galvanic corrosion? So, galvanic corrosion can be avoided by coupling metals close to the electrochemical series. As I told you, in the electrochemical series, hydrogen, it is considered to be the reference one. Hydrogen is considered to be the reference one. The metals which were placed above hydrogen are considered to be more anodic or more active metals. More anodic or more active metals. So, usually they have a tendency to involve in oxidation, thereby they involve in corrosion reaction. And similarly, the metals which were placed below hydrogen in the electrochemical series. So, these will act as more cathodic. As hydrogen, it is considered to be the reference one. The metals which were placed below the hydrogen in electrochemical series are more cathodic, or we will call them as more noble metals. So, if you select the metals in highest position in the electrochemical series, then usually there is a chance for formation of galvanic corrosion. And similarly, the metals that we choose very lowest position in the electrochemical series, then there is a chance for formation of galvanic cell on the surface of the anodic metal. So, for avoiding such kind of things, if you choose metals and going to couple the metals in the form of a cell which are very near to hydrogen, like these positions, near to the hydrogen in the electrochemical series, then this galvanic corrosion somehow can be prevented. And then fixing insulating material between the metals, between the two metals, so that contact will be avoided, so that corrosion reaction will be prevented. So because medium presence is there, then it is able to allow the flow of electrons from anode to cathode. So then corrosion will continue and it will spread up to the cathode place till the entire metal gets disintegrated. So fixing some kind of insulation material between the two metals will avoid the contact, direct contact of two different metals. So that is also one more prevention method for controlling corrosion reaction. So and then by using larger anodic metal and smaller cathodic metal also we can prevent galvanic corrosion. So this is what we call it as bimetallic type of corrosion, in which we can notice two dissimilar metals which are in mutual contact towards each other in the presence of a medium. So let us go with the second type, that is waterline corrosion. Waterline corrosion. So let us see what kind of mechanism it is adopted for explaining this type of concept. It has been observed in the case of an iron tank that is containing water. Say for example, I have considered the example of water stored in a container. This container, it is made up of steel or alloy of iron, say for example, and into which we have filled the water. It is not completely filled, it is like half filled, and this is nothing but water line. That is what we call it as water air interface. So that is what we call it as water line. If you notice, this is the metal, that is the tank. It is made up of only one metal, that is alloy of iron. And if you notice this interface, the areas above this interface are considered to be more oxygenated areas. That means availability, or we can say penetration of atmospheric oxygen will be more just above this interface, or we can call it as water line. Just above the water line, the areas are considered to be the areas with more penetration of oxygen, and just below the water line, the areas are considered to be poor oxygenated areas. That means penetration of oxygen will be less. So what will happen? Penetration of oxygen will be less. That means in this case, similar metals are in mutual contact towards the medium, with mutual contact with the medium or electrolyte of varying concentrations. Then such type of corrosion reaction is what we call it as waterline corrosion. So we are deciding that corrosion reaction, it is purely depending on waterline. Just above the waterline, the areas are considered to be cathodic in area, because penetration of oxygen will be less, and just below the waterline, the areas are considered to be anodic in nature, because penetration of oxygen will be very less in those areas. So at the anode, what will happen? Anode will always involve an oxidation reaction. So if you notice the reaction that is taking place at anode, say for example, this tank, it is made up of iron, then usually by involving in oxidation, by losing 2 electrons, it is able to release ferrous ions. So these ferrous ions along with the electrons will travel to cathode area with the help of this medium. There, what will happen? Penetration of oxygen or availability of oxygen will be more. So as we know in wet theory, cathode reaction proceeds via either evolution of hydrogen gas or absorption of oxygen gas. Those two conditions we have to apply. If the medium is example for acidic environment, then cathode reaction will proceed due to the evolution of hydrogen gas. So here I mentioned the reaction that is purely due to second case. That is, if the medium is an example for aqueous neutral environment, then cathode reaction proceeds via absorption of oxygen. So as I told you, aqueous medium, that means in the solution we will have water as solvent. That means it will contain water molecules as a solvent material. So in the presence of electrons and water molecules, that absorbed oxygen is able to release OH minus ions. So these OH minus ions combine with the ferrous ions, thereby producing ferrous hydroxide. These are able to form ferrous hydroxide, FeOH taken twice. This is nothing but mechanism involved in wet theory. So same kind of reactions will happen also here. So this type of corrosion reaction is what we call it as waterline corrosion. So it has been observed in the case of an iron tank containing water. That portion of iron tank just below the water level undergoes corrosion reaction. This is purely due to the difference in the concentration of oxygen that is available in the atmosphere. So corroding portion is poor in the availability of oxygen, and then it is acting like anode. Simply saying, if water it is stored in a container which is made up of iron, we have to consider this water line. The areas just above the water line are considered to be more oxygenated areas. So, and the areas just below the water line, these corners, will act like poor oxygenated areas. So, these areas will act like anode and more oxygenated areas will act like cathode. So, basing on that one, anode and cathode reactions will proceed and then corrosion reaction will proceed. That type of corrosion is what we call it as waterline corrosion. So, few more examples I am also going to explain you about this waterline corrosion, or simply we will call it as differential aeration corrosion also, because availability of oxygen whose concentration it is varying above and below the waterline. So, above the waterline oxygen it is more concentrated, below the waterline it is dilute in nature. That's why we will call this one as differential aeration corrosion. So, one more example, it is wire fencing. Wire fencing, generally we will use this wire fencing for plots, for telling, or we can say for identifying. So, up to this boundary it is my plot, like that. Okay. So, if this example, if it is considered, these areas are considered to be more oxygenated areas, and just below this wire, this area, these areas will be considered as anodic in nature. So, these are poor oxygenated areas and behave like anode, where the corrosion reaction will start. That means by involving in oxidation, metal is able to convert into corresponding metal ions, that is Mn plus, by losing n number of electrons. So, these metal ions along with the electrons will travel to cathode region, so that corrosion reaction will proceed. So, similarly, barricades, if they were fixed in river system, in sacred rivers, for giving a kind of getting a kind of a holy dip. So, for safety purpose, government people will provide barricades in river system, or we can say water system. So, this is also another example. Like wire fencing, barricades also will come under waterline corrosion. The areas which were exposed to water will have less oxygen availability, and the area which is exposed to atmosphere will have more oxygen availability. So, basing on that one, anode and cathode areas will be separated, so that reactions will correspondingly proceed. So, this is about waterline corrosion. So far, what we have discussed in today's session, it is, I explained about types of corrosion reaction, in which two I have explained. One is galvanic corrosion. Galvanic corrosion means it is nothing but bimetallic corrosion, in which two dissimilar metals which were existing and they were mutual contact in the presence of a medium. Then such type of corrosion is what we call it as galvanic corrosion. And then the second one, it is waterline corrosion. This is purely due to change in the concentration of availability of oxygen with respect to waterline. So, this is waterline corrosion. So, in the coming session, or in the next session, we are going to study about corrosion control methods, in which best example it is cathodic protection. That's all for today's class. Have a nice time. Thank you.